All right, guys, congratulations. You've made it to the final VOD of Unit 1. Today we're going to be discussing a little bit more about data. Okay, we're going to get into more detail on qualitative and quantitative data and accuracy and precision. So pretty interesting topics if you're a fan of numbers. If not, I'm sorry, grin and bear it. It'll be over soon. Quick and painless, all right? So first of all, let's talk about what data is. If you remember from the first VOD, we said that data was the results of an experiment. Any type of results that you get from an experiment when recorded are data regarding the experiment in itself. They can be qualitative and they can be quantitative, and we'll talk about this much more in depth. And if you'll see right here on the right, we have a graph. Most data is represented by graphs, okay? And this graph is kind of humorous, okay? It says your options when lifting a large spacecraft out of a swamp using the force according to Yoda. And if you're a fan of the Star Wars movies, you know that Yoda says, do or do not. There is no try. So understanding that data can be represented in graphs, whether they're pie graphs, bar graphs, or line graphs, is very important. And I'm sure you probably already know this stuff and have covered it since you were in early middle school, if not sooner. So this should be fairly familiar to you right now, and this should be kind of like a review. But this may not be as much quantitative and qualitative data. These are the two different splits, I guess you could say, that data is seen in. Quantitative data is strictly the numbers, okay? So as you can see, quantitative data has that N in it. The N stands for numbers, all right? So quantitative data has numbers, deals with things like grams, liters, time, temperature, things like that. Qualitative data examines the appearance or any type of visual change, something that you can see that changes or notice along those lines, all right? Qualitative and quantitative are both important, and I feel like that it is important when you're getting high quality data from your experiments that you have a nice balance between your quantitative data and your qualitative data in order to have a more functional experimental result process, okay? So I know it's kind of dorky, but in all truth, it's very true. You need to have a strong balance between your quantitative and qualitative data to get very, very effective results from your experiment. Now, what does quantitative and qualitative data look like? I'm going to jump on the whiteboard over here and show you a few examples. So you can see on the iPad screen where we have a number of different examples of quantitative and qualitative data. Now, how these are classified is another question altogether. So what do you think? Is a growth of 2 centimeters qualitative or quantitative data? If you said quantitative data, you're exactly right. Is a height of 4 meters quantitative or qualitative data? If you said quantitative, you're exactly right. Now why? It's because of these numbers, right? It deals with numbers having a quantity to display. Now, how about this example right here, which says a color change from blue to red? Is that going to be qualitative or quantitative data? This, in this case, would be qualitative data. It would involve a change from blue to red, something visual that you noticed. How about the production of bubbles? That's going to be qualitative data also. Now, these two right here, volume of 3 liters and it took 2 days, these are both going to be quantitative data. This is because, once again, they involve that numbers thing. Now, the most high-quality data you're going to see is going to be coming from the final answer right here. The final answer says that it changed state at 100 degrees Celsius. Now, why is that effective? Because it tells you that you noticed a change, and it also mentions the temperature at which the change occurred. So having a nice mix of the two leads to better results and more effective data presentation, okay? You want to have a nice blend of your yin and yang to have effective data presentation. That brings us to the last little topic of discussion for this chapter, or this unit. Precision and accuracy of results. What is precision? What is accuracy? I know you've probably heard these terms thrown around a lot, but what do they mean in terms of data? Well, precision is the repeatability of a result, and accuracy is the ability to match the actual value of a quantity. So that may sound like a bunch of mumbo-jumbo, but I'll give you a few examples. The first of these involves these targets. Which of these has the highest precision? Which of these has the highest accuracy? If you look at them, number 3 has arrows scattered all over the place. Number 2 has arrows centralized along one point but not quite on the bullseye. And number 1 has all the arrows really, really close together and on the bullseye. Which of these do you think is the most accurate? If you've ever played darts before, what are you shooting for? The bullseye, correct? Okay, well, actually the most accurate of these would be number 1. Number 1 because all of the arrows are within the bullseye. Now, which would be the least accurate? Least accurate would be number 3. That's because none of them are really close together. None of them are really even close to coming into contact with the bullseye. How about number 2? What's going on here? Number 2 happens to have high precision, and it also tends to have a little bit lower accuracy. Okay, so moderate accuracy. Now, what is precision? As you can see, even though the result wasn't as accurate as possible to this known value or the bullseye, although they weren't all on point with the bullseye, they were all really, really close together. So that means that the result was very, very repeatable, making their result precise. Now, target 1 is also precise. All those data points are real close together, and it's very, very accurate also. So which of these do you think is going to be the most effective data? Actually, number 1 would be. If you guessed that, you're on a roll, all right? Number 1 is going to be the most effective data because it is A, close to the actual result, making it accurate, and B, has a very, very high repeatability of the result. So let's see an example of that using numbers. Here's a good example. As you can see, we have 4 different data points and another number on the outside. The number on the outside, written in red, indicates the actual value, okay? The bullseye for our data points. The numbers on the inside are all of the results of a lab trial, we'll say, okay? So we have 5.4, 5.4, 5.5, 5.6, okay? So would you say that the result was fairly repeatable? They were all within 0.2 of one another, right? They were all really close together. So this is actually going to be very precise. Now, was it accurate? On average, you're probably going to say yes. All these are very, very close to 5.4. So that would make it accurate. Okay, so it's very accurate and very precise. So this would be a high quality set of data. Now, let's take a look at something that's not as good. This right here, what do you think it is? We have the numbers 4.4, 3.3, 2.2, 1.1, and the expected value that we were supposed to get was 5.6. How does this set of data look in terms of accuracy and precision? It's actually going to be not accurate, not precise. None of the data points are even close to one another, let alone are they all close to the expected value. Okay? So now we can kind of tie this into what we discussed in the second video of this unit, and that was the error of a system, okay? So we have this system that had an average. I weighted it and scaled it, so it was 4.4, 3.3, 2.2, and 1.1, and they all average out to be 2.75, okay? And to do that, you take this, plus this, plus this, plus this, and divide it all by 4 because you had 4 observations. Now, this was the observed value. Remember that from the error thing. This was observed. Now, the expected value we should have seen was 5.6. Now, we have 2.75 minus 5.6 all over 5.6. Okay? You remember that formula. This was the formula for error, and we multiply all that by 100. So when we do that and we plug and chug it in our calculators, what do we get? Okay, remember, you're going to get a negative answer here, but we can't have negative in error, correct? So actually the number you're going to get is 50.9, roughly, percent. I rounded a little bit on the tail end there. So this is not a very, very sound measurement. 50.9% is much different than what it should be. You want to have small amounts of error. Remember, under 5% to get full credit on your assignments. So this ain't going to work. All right? Okay, once again, guys, if y'all have any questions, come in for activity period or ask me during the Give Me 5 session tomorrow during class. Be ready for the flipping quiz, okay? You guys have a great evening.